Good afternoon, everyone. So, the topic that I have been asked to talk about is future trends and challenges of Industry 4.0. So, I think that the word itself is in the workshop. So, I'm sure many of the speakers would have talked about what is Industry 4.0. And since I have come perhaps second or third day, so I think you may be aware of what is Industry 4.0. So when I say there is 4.0, so there must be some other number, 3.0, 2.0, 1.0, and if at all, if it started from 0.0. So there is a progression in that, right? So what drives this 4.0? And what is the need of even classifying all these things? Is it just a marketing, terminology that keeps propping up in industries just for gaining more funding? Words like deep tech, words like interchangeably words like machine learning and AI. Right? What is it? What defines the human technological evolution in such a way that we say that we are now at the at 4.0 level? What defines that?
Digital automation.
Digital automation. So there must be some other automation as well. When you have qualified automation with digital, so there is some other automation as well, right? No, I'm not denying what you're saying. I'm just trying to qualify it. Because when you say digital automation, you mean to say that automation is either driven by digital means, yes, or it is through digital means.
Automation through digital means.
Right. So that means the automation is a word that was already there. So the earlier some industry, let's say X.0, N.0, had automation in them, isn't it? And that's the crux of the whole man-machine interaction, the technology that we are trying to work with. We want to automate stuff, right? We want to automate stuff. It could be done through some devices, mechanical devices, through actuators, right? Which may or may not be digitally controlled. Okay? So when we say 4.0, it specifically defines or inculcates cyber physical systems, IoT, right? And automation. Here automation is digital automation to create intelligent factories. Can you give me some example? I have put some examples here, but they are not very concrete examples. These are words: cyber physical systems, connected machines, IoT, AI and automation, smart automation, data driven, right? Now there is one more thing, that these all devices could also be connected or talking to each other, right? I'll give you some examples later on. The real devices that we have developed, what are the different protocols, what is it that we do in these things? So these are, now what's the full form of IoT? Of things. What are things here?
Anything which we come across in day-to-day life.
So in that sense, can I make a pen as a IoT device?
Yes.
Yes, if I could plug something by which it can talk to each other or talk to internet, it could do that. So the idea is to create such devices which can sample the environment, and by sample I mean which can take some information of the environment. It could be temperature, humidity. If it is an agriculture application, then soil conductivity, or even the vibrations. If it is a vision based device, then the images, RGB images, thermal images, or if it is something like on a let's say on a flying or moving vehicle. Then you have radars and all the different kinds of sensors which can sample the environment, and that data could be sent over for either storing or doing some calculations, right? And then the gist of the information could be sent back via some personal digital assistant or some user interface, right? So in that sense, in this whole process, there is one which is collecting data, there is an interface which sends the data to the internet, there is an interface which does some kind of thing at the at the cloud, some kind of analysis, and then gives back information to the, so there is some autonomous decision making as well, right? There is some kind of decision making which is happening at every stage. Now this decision making could be simple rule based, कि भाई यहाँ डाला, if this is there then do this, right? Humidity sensor यहाँ पे temperature ये है, कुछ बढ़ गया तो give some kind of, it could simply be rule based, or it could be a system which learns, जिसमें कि शुरू में I don't know, in the beginning I don't know ये क्या हो रहा है, क्या होगा, right? I try to learn from the environment as we do. शुरू में, let's say we want to learn about something, maybe we don't know, we have some hypothesis, of course. उसी की तरह से there are some hypotheses there as well. Then later on, what we do is we learn from the environment and then we take decisions. So as I said, there is a timeline that people have put on. So it's from some reference. So it was in 1784, and I'm sure you must be aware since it is the second day. So this kind of timeline must have come across you, right? 1784 was 1.0. See, these are not hard deadlines. Somebody has put some number to it. We like to put some number to everything so that it can be comprehensible. It's not as if 1784 was the beginning of 1.0 and people decided that this is 1.0. This is retrospective as well. So this started with steam engine. So that's perhaps the start of the automation. You want a train to move automatically through some energy source. So steam engine, that's where perhaps people say the industrial revolution started. That's what gave the edge to the Western civilization, right? And that's what is giving edge till now to the Western civilization, the industrial revolution. And among them many other things. So, and 2.0 was when electricity, assembly lines, all of these things started to come along in the industry. Around 1969, you had the advent of computers. By computers, it does not mean the computers which were very large, gathering too much of power, but the computers which could be put in, on desks, put at different places, and which consumed less power. So you had a very large scale. You could have very large scale system, VLSI design, and all those things. That started being fabricated, and then we are on to 4.0. There is something 5.0 as well, which talks about, so you have internet connection, device data acquisition, data analysis and simulation, part of 4.0. There is something called as 5.0 as well. So where what they say is, it's not only about the automation and internet and the AI, it's human in the loop as well. So it's like we are going back on the circle. They started understanding that if we start automating things, it's everywhere and indiscriminately. First, it tends to loss of jobs. Second, machines do not have, at least till now, the fundamentals of ethical responsibility, right, and the morality of the societal nature, the cultural norms as well. So the human in the loop thing came along, so that humans will operate with machines, and machines will have to take decisions in which humans will be involved. So that's beyond 4.0. What you see here is in stats, the rise of 4.0. First graph is saying the industries, the companies which had Industry 4.0 as the crux of their technology, how many of them got acquired. So you can clearly see the number is actually increasing, except the brief period of COVID in which they started getting acquired. So, and the fundings as well. So these are number of funding rounds and the funds that started gathering. So you can see the numbers. It's increasing, right? So Industry 4.0 is something which is real. It is by real I mean to them there is a real money involved in that. And this is a relative search interest on Google as well. So it gives you stats of how many people have asked about Industry 4.0. It has started increasing about let's say some of the words like cobots, cohabitation bots, digital twins, additive manufacturing. You'll have a session on that as well, and machine vision. You'll see that there is a certain increase. Unlike there is a certain increase, there are some of them which had an interest earlier as well, for example machine vision, but they have started increasing. Similarly, the Industry 4.0, the search itself, except for the brief period of COVID, around COVID, you see that there is an increase in interest of Industry 4.0. What are the key characteristics? There are lots of things, words that you will see here, and I may, I think we have talked about almost all of the things. Perhaps one or two things that we have not talked about are smart supply chains, customization, and human-machine collaboration. Now, human-machine collaboration is something that is also part of Industry 5.0. And also, when I say smart supply chain, could I also include sanctity of the chain of sanctity of the products? By that I mean, let us say if somebody said that I am giving you, let's say, Y certified something, or a product which is fresh from XYZ place. Now, if it reaches you and if it is not fresh, then there is a loss. So there should be a mechanism in which freshness is intact. So that forms part of the technology itself. Something like let's say one of the examples as cold chain solutions. Vaccines go from one place to another, and they have to be at a certain temperature, right? Now there has to be some logging, some kind of instrumentation, some kind of instruments, some kind of intelligence by which there is a logging as well, and there is a cold supply, there is a temperature maintenance as well, right? So that's one of the examples. Or something like a blockchain as well, right? In which between two people in which the contract is being signed, there is a sanctity of the contract, right? Blockchain in supply systems as well. So there are lots of things that could be part of the smart supply chains. And there's one more thing that I have not talked about, and it should be talked. It was part of the earlier slide as well, is the digital twin technology. Now it will not only involve the mechanical design that we anyways know of digitizing. Many of you are from mechanical, so you are aware of designing things on softwares, mechanical engineering softwares, design softwares. So it does not only involve the mechanical design, it also involves the functioning, digital twin of the functioning of things. So for that, you need to have a clear-cut transfer function. There are optical systems involved, right? There are optical systems involved. So you need to have models by which you could put the optical systems, you can throw some light and see the output as well, correct? There are electrical systems involved, right? There is a chip which takes the voltage, let's say voltage at certain frequency, and then it lights up some LEDs, right? Some kind of power source is there, and then there's some kind of intelligence to project it at some place, right? So you need to make digital twins in order to understand the functional characteristic of the system, so that you can make it better, you can diagnose it, right? And you can take decisions. Now, this is a simple, by simple I mean this is a very small system that I talked about. It may not be simple, but there are biological systems as well. For example, you could even try and understand and make a digital twin of the growth of the plant itself, right? From the beginning itself, what you start doing is you try and get the growth pattern using some kind of vision technology, and what is it that you are inputting, and from the fundamental principles of the growth of the plants, you start developing the models. Now you'd say, why do I want to do that? Exactly, isn't it? That way I will know, if I have a proper digital twin, I will know if I input something, what will be my output, or if there is no such input, what is the effect on the growth. It's not something out of science fiction that I am talking about. People are doing it across the world. They are trying to develop such kind of systems. They have developed such kind of systems, rather to say this, right? Sometimes what happens is, in our own world view, we start thinking, अरे ये सब science fiction की, ये सब नहीं चलता है. नहीं, ऐसा हमेशा नहीं होता है. There are sometimes that these things happen, but yes, there are people who have some kind of vision and they are doing it, right? One of the very important thing that digital twin technology offers is if you have large systems, you can maintain them and even do predictive health monitoring. Let us say if I have a big turbine, if I could make a digital twin out of it, then and have sensors by which I can get the data of the health of the system itself, then I could perhaps, with the historical data and the present data, I could predict when it will need a maintenance, or when there will be a failure. So, and these things are going on. It's not, I'm not talking anything out of only as a theoretical part of it, or these things are going on. People are doing it. Big wind turbines, I have my friends in ABB Robotics and all those these companies, they are doing all these things. They are already doing all these things, right? So, in these cases, digital twins are, so for all of this, you have to have some understanding of the basics of this system development, the design aspect, system development, and core engineering principles, right? So, there is, now one of the paths is hyper automation, Industry 4.0. It combines artificial intelligence, robotic process automation, and in turn creates an intelligent automation as well. So why this kind of hyper automation matters in Industry 4.0 is since manual intervention creates lots of high cost, and may have low consistency, and the machines, if they are maintained well, they can work for 24 hours. I think you must be aware of these dark labs, dark floors. I don't know if you have heard these kinds of these words. So there are many factories in China and some of them in America as well, where the whole store where the manufacturing is being done is devoid of any human presence. it is being completely guided by machines itself. And again, I'm not talking this out of science fiction. This is there. This is happening today. Okay, so you have these systems. Why these things are happening? There could be many reasons. First is, of course, they may not have those kinds of skilled people, for one. But the main thing is, in manufacturing, sometimes humans bring with themselves some kind of, some other kind of foreign materials with them as well. Now, if you want to have such kind of clean room, such kind of clean fabrication facility, so you need to automate all of these stuff. These machines are anyway sterilized, and they're in a certain environment which can be sterilized at will. So you have those kinds of systems. So, and then they reduce the manual intervention. That's why, and then of course they optimize the production flow. But all of this I'll end with I'll put a caveat around it. It's not as if hyper-automation solves the problem. Just 2-3 days back, I was talking to an orthopedic surgeon. What he was saying is, there is a lot of hoopla around robotic surgery. You must have seen in the newer private hospitals, or even the government hospitals, that they do the knee surgery. They are doing the knee surgery with the help of automation, automatic robots. And they say that the precision is wonderful and all those things. So there is some kind of registration being done, some kind of imaging is being done, so that they clearly know what happens there. Now, what has happened there is, sometimes, not in all of the times, sometimes the surgery takes a longer time. Let us say a human being was able to do it in, let's say, 1 hour. It takes 2.5 hours. More time on the surgical table, more chance of infection, right? And sometimes due to human interventions, other kind of registration problems, what has happened is they have to cut it at this place, they start cutting at some other place. So there have been some kinds of problems. So what has happened is, as he was telling me, that UK has stopped doing such kind of surgeries. I'm not fully aware of that, but yes, I take his point. So it's not as if there is a goody things there. When there is at least the health interaction is there between patients and the doctors, we have to be very careful when we are trying to automate things. Okay, so as I said earlier, real-time models can forecast failures, and they optimize energy and dynamically adjust production parameters. So warehouse management is one of the parts of it, where you could you could very easily put things in a way in which the distance between one product to another, in terms of the whole design, in terms of the whole production itself, is reduced. Okay, so and then you could have in the quality control and defect detection as well, you could have automation. There are lots of things. One of the examples, I would say, some company approached me for what they were having is there were factories in which they were producing big stitching big clothes as well. So it was not a stitching thing, but it was a manufacturing of the cloth line. So at some places there were some defects. Now those defects were identified by people on the assembly line, those who were very good at it, and they would generally miss all of these things. Sometimes they'll miss, and that led to quite a bit of loss of the whole line itself, So they wanted to understand if all of this, if that can be done through some kind of instrumentation, some kind of sensing technology, some kind of intelligent sensing technology. Now, can any one of you tell me what could be done here? When I say defect, it could be a defect of, let's say, they wanted of one thread coming out, or one thread less, or even a tear. Understood? So what could be done here? If you have a class and you have such a less data in terms of count, what do you do there? you said that you want to create such kind of data sets in which you will label that this is a defective piece, this is a non-defective piece. Now you go to the factory, consider एक solution engineer की तरह सोचो इस चीज़ को, है ना. आप फैक्ट्री में गए, आपको कहा गया कि ये करना है, तो कहोगे ठीक है, अच्छा मैं ना डेटा सेट क्रिएट करता हूँ, मैं 2 को रखता हूँ इंजीनियर्स को अपने पास, सॉफ्टवेयर डेवलपर का मुझे ये काम करना है. यू अंडरस्टैंड, मैं थ्योरेटिकल बात किताब पे नहीं कह रहा हूँ, मैं कह रहा हूँ फ्लोर पे जाके आपको ये करना है. 2 इंजीनियर आपको दे दिए गए हैं सॉफ्टवेयर डेवलपर, तो आपको कहे कि अच्छा ठीक है डेटा सेट क्रिएट करो. तो आप कहोगे अच्छा मुझे डेटा बताओ आपके पास कैसे होगा. तो आप कहोगे ऐसा करते हैं कि एक कैमरा वहाँ लगा देते हैं, ठीक है, और वो फोटो हमेशा लेता रहेगा, लेट्स से 5 फ्रेम्स पर सेकेंड, 10 फ्रेम्स पर सेकेंड, व्हाटएवर जो भी आप स्पेसिफिकेशन सोचते हो. बट उसके लिए भी आपको देखना पड़ेगा किस स्पीड से वो फ्लोर पे आ रहा है, आपके कैमरे की स्पीड क्या है. वो चला गया जब तक आपने देखा नहीं, सो यू हैव टू, लेट्स से यू डिसाइड ऑल दीस थिंग्स, आपने ये मिलके डिसाइड कर लिया. नाउ यू स्टार्टेड गेटिंग द डेटा, ठीक है, एंड समबडी डाउन द लाइन वो अभी भी मैनुअली कर रहा है कि ये डिफेक्टिव है, नॉट डिफेक्टिव है. आप उससे बात करते हैं एंड देयर सम काइंड ऑफ टैगिंग आपने कर रखी है, दिस इज इस लाइन का फर्स्ट ये है, तो वहाँ पे गया तो सम काइंड ऑफ सिंक्रोनाइजेशन एंड यू नो. नाउ सिंस इट इज़ अ गुड फैक्ट्री, इनके 10,000 ऐसे मान लो 5x5 के, आई एम जस्ट सेइंग 5 मीटर बाय 5 मीटर के साइज में एक डिफेक्ट आता है ऑन एन एवरेज, या 1000 में एक आता है, राइट. तो आपको डिफेक्टिव पीसेस का तो डेटा ही बहुत कम आया. यू अंडरस्टैंड व्हाट आई एम सेइंग. कैसे मॉडल बनाओगे फिर. आई विल टेल यू वन मोर एग्जांपल. आप लोग सब GPUs यूज करते होगे, सम ऑफ देम यू वुड बी यूजिंग GPUs. GPUs आर एनर्जी गजलिंग devices, right? People are creating data centers. You must be reading in the news or the tech news and all those things. Sorry?
Under the ocean, they are creating.
Yeah, under the oceans, and there are lots of different kinds of, and Tesla is creating big, or even all the companies, they are creating big data centers with GPUs and other kinds of processors there, and they are equivalent to taking the energy that they take is equivalent to a whole big metropolitan city, and it is incredulous, isn't it, that we have such kind of big setups which take up energy, and then when we have people where there is no energy, right?